Howdy folks. What we're going to do now is you've already learned about z-scores and how to use a standard normal cumulative probability table to find p-values with a z-score. But what we haven't done yet is you haven't taken a set of data and identified the mean and the standard deviation on your own and then found z-scores. See, I've taught you how to take data and identify the mean, standard deviation, variance, and all that stuff. And I've taught you how to find the z-score and find p-values. But what we're going to do today is we're going to do all of it from beginning to end. Okay? So here we have this situation, and you're gonna want to open up Excel in your computer. You're going to need Excel so that you can identify the mean and the standard deviation. So we got this situation that says a candy manufacturer has a variety bag of candy that is sold by weight. But because each type of candy in the bag is a different weight, the bags can have a different number of pieces of candy in each bag. A production manager took a sample of bags and counted how many pieces were in each bag. And these are the results. Okay? So he took a whole bunch of bags and he just poured them out and counted how many pieces of candy were in each bag to see how many pieces of candy you're likely to get in a variety bag of candy. And so here's what I want you to do. I want you to pause the video and I want you to enter all of these numbers into Excel in a column. And then what we'll do is we will take that data and we will identify the mean and the standard deviation. Okay, you can see here now, I've put all the numbers in from one. It looks like there's 30 numbers. And so now I'm going to go ahead over here and I'm going to calculate I'm going to run the descriptive statistics, okay? All right, so to run the descriptive statistics, of course, we're going to first go up to data at the top, and then we're going to click on data analysis, and it's going to open up our data analysis box here, and we're going to click on descriptive statistics and then click OK, and then under input range we're going to click on this right here, and then we're going to select all of our numbers and press enter. Then we're going to make sure that there's no checkbox here. Labels in first row do not have a checkbox here. Then we're going to go down here to output range, and we're going to click here, and then we're going to click on this thing. And let's put the output maybe right about here. That's a good spot for it. And then we'll press enter. And then down here we want to click on summary statistics. And then we'll click OK. And I'm going to widen this up a little bit so that we can see. And you can see here now, there's all of our data right there. I'm going to put this up. And I want you to notice the two pieces of information that we need is we need the mean, which is 127.1, and we need the standard deviation, which is about 9.1, okay? So I'm going to write that up here at the top. I'm going to say that x bar is equal to 127.1, and the standard deviation is 9.1, okay? And now what we're going to do is I'm going to turn off the projector, and we're going to answer some questions about these bags of candy at this candy manufacturer. All right, so the first thing we're going to do is we're going to sketch a normal distribution curve, okay? All right, so basically we just want to draw a basic bell curve, right? And then here we're going to mark the middle, which we're going to put the mean at, right? And then we want 3 standard deviations over one direction and 3 standard deviations over in the other direction. Now you may want to pause the video now and do this on your own based on the mean and the standard deviation. All right, so let's see here. Let's see if you did it right. We'll put the mean, 127.1 here. Then we're going to go up by 1 standard deviation at a time, 9.1. So 127.1 plus 9.1 is going to be 136.2, and then 145.3, and then 154.4. Then we're going to go down by 9.1 at a time. So we're going to subtract 9.1 here, and we're going to have 118. It should be 118. then subtract 9.1 again, and we'll get 108.9, and then we'll have 99.8 will be our last one, okay? So this is a standard, this is a normal distribution curve based on this information. Now let's go on to the next question. All right, so here's a question. What proportion of bags have fewer than 115 pieces of candy in them? Okay, well, if we want to find a proportion, right, and we're given a particular X value, we want to identify a z-score. We need a z-score, and we need to use the z table to be able to find this proportion. So what we're going to do is we've got to use our z-score calculation, which is z equals x minus x bar over standard deviation. So the z-score for 115 is going to be 115 minus 127.1 divided by 9.1. And we're going to need a calculator to be able to calculate that. So I'll get a calculator, and we're going to do 115 minus 127.1, enter. Then I'm going to divide that by 9.1, and I get a z-score. Now remember, I need to round my z-score to 2 decimal places. I get negative 1.32967, but that's going to be rounded to negative 1.33. So that's my z-score. Now I want to turn this z-score into a p-value, right? So I'm going to go in the table, and I'm going to look for negative 1.33. And I find negative 1.3, and then over to the column that has the 3 at the top, and I get 0.0918. 0.0918. And because this question is a less than question, it says fewer than 115. That's a less than question. And remember, with less than questions, the answer you get from the table is the correct answer. And therefore, what proportion of bags have fewer than 115 pieces of candy in them? It's going to be about 0.0918 of the bags. Now let's try another question, maybe a more than question. All right, so this question says, what proportion of bags have more than 130 pieces of candy in it? Well, we're going to answer this the exact same way we did the less than question, only this time we got to change up the p-value because this is a more than question. But the first thing we need is we need a z-score that goes with 130. So we're going to do z is equal to 130 minus 127.1 divided by 9.1. We'll do that in the calculator. 130 minus 127.1. That gives us 2.9 divided by 9.1. That gives us it's rounded to 0.32. Now it says 0.318, but the 8 turns the 1 into a 2. So our z-score is 0.32. We'll go into the z table and find 0.32. And I see 0.3, and I'll go over to the column where the 2 is at the top, and I get 0.6255. P equals 0.6255. Okay, 0.6255. Now, this is a more than question, and this proportion is the less than proportion. This is actually the proportion of bags that have less than 130 pieces of candy. So in order to turn it into a more than, we have to subtract this from 1. So we're going to do 1 minus 0.6255. And so we go into our calculator, we'll do 1 minus 0.6255, and we get 0.3745. So our answer, P equals 0.3745. The proportion of bags that have more than 130 pieces of candy in it is going to be 0.3745. Okay? Now let's try a between question. Okay, so this question says, what proportion of bags have between 120 and 140 pieces of candy? Okay, so what we need is we actually need 2 z-scores, one for 120 and 1 z-score for 140. Okay, so we're going to have z is equal to 120 minus 127.1 over 9.1, and our other z-score is going to be 140 minus 127.1 divided by 9.1. All right, let's see what we've got here. 120 minus 127.1. That gives me negative 7.1 divided by 9.1 gives me rounded negative 0.78. Negative 0.78. And now over here, we'll do 140 minus 127.1 divided by 9.1 gives us 1.42. After it's rounded, it's positive 1.42. Now we need a p-value associated with this z-score and associated with this z-score. So p equals. We'll go in the table and we'll find negative 0.78. So I got negative 0.7. Now I'll go over to the column where it has an 8 at the top, and I have 0.2177. 2177. Now over here, we'll find 1.42. I see 1.4. Go over to the column with the 2 at the top, and I got 0.9222. 0.9222. Okay? So I've got two p-values. Now remember, these are both less than p-values. So if I want to find the between p-value, I have to subtract the larger p-value minus the smaller p-value. So I got to do 0.9222 minus 0.2177. Okay? All right, so I'll do 0.9222 minus 0.2177, and that gives me a p-value of 0.7045. So the proportion of bags that have between 120 pieces of candy and 140 pieces of candy is 0.7045. And what that means is basically, well, one way of thinking about it is you have a 70.45% chance of grabbing a bag out of a box or off of a pallet or in the store, and there's a 70.45% probability that there's going to be between 120 and 140 pieces of candy in that bag that you grabbed, okay? Which means that there's about a 30% chance that there will be either more than 140 or less than 120, okay? Let's do another kind of problem. Now we'll do some how many problems. All right, here's a situation. One day, that company, okay, they produced 16,300 bags of candy. How many of those bags probably have less than 130 pieces of candy in them, okay? Now, with how many questions, remember, all we do is we find the proportion first, like we just did. We just did a few of those. You just find the p-value, the proportion, and then multiply the proportion times the population. And so in this case, the population produced in that day was 16,300. So we would say that capital N is 16,300 bags, okay? So let's go ahead and find a z-score associated with 130. So z is equal to 130 minus 127.1 over 9.1. All right, so 130 minus 127.1 divided by 9.1, and that gives us 0.32. And now we're going to turn that into a p-value. So go into the table and find 0.32. 0.32, 0.6255. And I know we just did that same number in a previous question. But sometimes you come up with the same z-scores and the same p-values sometimes. But in this case, we're going to keep the 0.6255. That's our p-value. So the proportion of bags that have less than 130 pieces of candy in them is 0.6255. But now we have to multiply this number times the population. So we're going to multiply 0.6255 times the population, 16,300 bags. And that will give us approximately, it's probably not going to be, well, it might be precise, but we'll put an approximately just in case. All right, so 0.6255 times 16,300. It is approximate because we have a decimal here. We want to round to the nearest bag because we can only give our answer in whole bags. 10,196 bags. So about 10,196 of these bags are going to have fewer or less than 130 pieces of candy in them. Okay. Now let's try a how many have more than. Okay. All right, now this question is asking a very similar question, only it's asking how many of the bags probably have more than 150 pieces of candy. Well, the procedure's the same, only we got to add one more step because this is a more than. So when we get a p-value, we have to subtract it from 1, right? So we're going to find a z-score for 150. So z is equal to 150 minus 127.1 divided by 9.1. So 150 minus 127.1 divided by 9.1 is going to be 2.52, about 2.52. We're going to turn that z-score into a p-value. So we go into the table, 2.52 gives us 0.9941, 0.9941. Now this is the less than p-value, so we have to subtract it from 1. 1 minus 0.9941 is equal to 1 minus 0.9941 gives us 0.0059. 0059. That's a very small, that's less than 1%. Okay, so not very many bags. But we have to multiply this number, 0059, times the number of bags produced on that day, which is 16,300 bags. So let's multiply this number times 16,300, and we get 96.17, or let's say approximately 96 bags. Now, wouldn't you like to be one of the people that gets one of those 96 bags with more than 150 pieces of candy in it? Of course, these bags are produced by weight, so it's not like the person is actually getting more candy in weight or in sugar. They're just getting more pieces of candy. So they probably got more smaller pieces and fewer larger pieces of candy. Okay? Let's do just maybe one or two more kinds of questions here, and then you should feel pretty confident with doing this. All right, so this is a between question. It's the day they produced 16,300. How many of the bags probably have between 116 and 142 pieces of candy? So now we need two z-scores, one for each of these numbers. So we're going to have z is equal to 116 minus 127.1 over 9.1. And the other z-score is going to be 142 minus 127.1 over 9.1. And so let's do this one over here first. 116 minus 127.1, and then we're going to divide that by 9.1. That's going to give us negative, this is rounded, negative 1.22. Negative 1.22. And over here we're going to have 142 minus 127.1. We're going to divide that by 9.1. That's going to give us 1.64. 1.64. Now that's rounded, okay? So now we're going to turn this into a p-value, and we're going to turn this one into a p-value. So go in the table, we're going to looking for negative 1.22, and I get 0.1112. 0.1112. Then this p-value, 1.64, looks like 0.9495. 9495. Now, before I do any multiplying by the population, I need to subtract these two p-values so that I can get the proportion between. So I'm going to do 0.9495 minus 0.1112, and that gives me a p-value, a final p-value between p-value of 0.8383. And then I want to multiply that proportion times the population of bags produced that day, 16,300 bags, so times 16,300, and we get approximately equal to 13,664 bags. So that's a good number of bags that have between 116 and 142. And so they could probably tell people, you'll probably get about 120 pieces of candy in there, give or take a few. All right? Okay, we only have a couple more kind of questions to do. We want to do the cutoff score questions. All right, so this question says, what is the most pieces of candy, or the most number of pieces of candy in the bottom 8% of bags? So the 8% of the bags that have the fewest number of pieces of candy in them, we want to know what the highest number that is. So this is because it's asking for the bottom percent, that number of pieces of candy, that's the most that is in any one of those bags. So we want to take our 8% and we want to turn it into a decimal. So we're going to do 8 divided by 100 is 0.08. Add a couple more zeros because all of our p-values are 4 digits. Then, since it's the bottom 8%, this is actually the decimal value we want to use. That is our p-value that we're going to look for. So we're going to look for 0.08 in this table, 0800. So if I look in the table, I see 0.0808, 0.0808, and I see 0.0793, 0.0793. This one is 0008 away, and this one is 0007 away. So I'm going to go with this one, 0793. And the z-score associated with that is negative 1.41. So this becomes a z-score of negative 1.41. Okay? Now, we're going to take that z-score and we're going to put it in the z-score formula. So we're going to have z, negative 1.41, is equal to x minus the mean, 127.1, divided by the standard deviation, 9.1. And now we're going to solve algebraically. We're going to multiply by 9.1 on both sides. Cancel here. And over there, negative 1.41 times 9.1 gives me negative 12.831. And that's going to be equal to x minus 127.1. Now I'm going to add 127.1 to both sides. And that's going to give me x equals 114.269. 114.269. So what we'll say is about 114. So x equals 114 pieces of candy. So any bag that has 114 pieces of candy or fewer than 114 pieces of candy is in the bottom 8% of all the bags. Okay? Let's try just a couple more. All right, so this question says how much candy is in the top 3% of bags? So this is a top percentage, all right? Our first step is to turn our percentage 3 into a decimal. So we'll do 3 divided by 100, and that gives us 0.0300. 0.03, but I'm adding a couple more zeros because all the p-values on this table are 4 digits. Now it says the top 3%. So with the top percentage, because everything in this table is a lower proportion, we need to turn this into a lower proportion instead of an upper proportion. So we have to do 1 minus 0.0300, which would give us 0.9700. And that's the p-value that we're going to look up in the table, 0.9700. So if I look up in the table, I see 0.97, where is it? 0.97, 9686, 9693. Oh, I got a 0.9699. 0.9699. That's the closest that there is to 0.9700. So the z-score associated with 0.9699 is 1.88. So this becomes a z-score of 1.88. 1.88. So now we're going to take our z-score, 1.88, and we're going to set it equal to the z-score formula, which is x minus x bar. But we know x bar, that's 127.1. We're going to divide it by 9.1. So, and now we're going to do some algebra. We're going to multiply by 9.1 on both sides. That's going to cancel on this side. We're going to multiply this by 9.1. And 9.1 times 1.88 is 17.108. 17.108. That's equal to x minus 127.1. Now we're going to add 127.1 to both sides. And that gives us, it's going to cancel on this side, 144.208. All right. And so we're going to say about 144. We're going to say that it's approximately equal to 144 pieces of candy. That means that there is at least 144 pieces of candy in the top 3% of bags. The 3% of bags that have the most candy in them have at least 144 pieces of candy in them. Okay? Now let's try a middle percentage question. All right, this question says, how much candy is in the middle 55% of bags? So we want to first turn our 55% into a decimal. So we're going to do 55 divided by 100. That gives us 0.5500. Now remember, with a middle percentage, we want to find two cutoff scores, right? Two cutoff scores. And so since the middle percentage is between them, we know that whatever's left over, the percentage that's left over, which would be 45%. If 55% is in the middle, 45%, the rest of it, is in the two tails. And we have to split that 45% between the bottom tail and the top tail. Okay? So we want to first subtract this from 1 to get what percentage is not in the middle, or what proportion is not in the middle. So 1 minus 0.55 is 0.4500. And then we want to split that percentage in half and put half of it in the bottom tail and half of it in the top tail. Okay? So we're going to divide this by 2, and that's going to give us 0.2250. Okay? And this is the p-value we're looking for. So let me show you what it's going to look like on the distribution curve. You're going to have 0.225 over here, and you're going to have 0.225 over here. So the 22.5% here and 22.5% here, that's going to give us two z-scores. One z-score right here and another z-score right here. These are going to be the same number, and one of them is going to be negative and one of them is going to be positive. So we really only have to look for one z-score and then just make it plus or minus. Okay? So this is the z-score we're going to look up right here. We're going to look up 0.225 as the lower proportion. That'll give us a negative z-score, and then we'll make it positive or negative. So get my table here, and I'm looking up 0.2250, and I find 0.2206, 2236, 2266. All right, I got 0.2236, and I have 0.2266. So this one is 0016 away, and this one is 0014 away, because 36 plus 14 is 50. So this is the one I'm looking for, 0.2236. So 0.2236, there it is. I've got negative 0.76. So it's z equals plus or minus 0.76. That's our z-score. Let me erase some of this stuff. Erase this here. And now we need two scores, two x values. One of them is associated with negative 0.76. The other one is associated with positive 0.76. So we're going to say that this is equal to x minus the mean, 127.1, divided by 9.1. This one is going to be equal to x minus 127.1 divided by 9.1. We're going to do algebra on both of them. So let's do this one first. Times 9.1 cancels, times 9.1. So 9.1 times negative 0.76 gives us negative 6.916. Negative 6.916 is equal to x minus 127.1. Now we're going to add 127.1, add 127.1, add 127.1, cancel, and we get x is equal to 120.184 over here. Now let's solve this one. Get rid of this z-score. Again, we're going to multiply both sides by 9.1. Multiply by 9.1. 9.1 times 0.76 gives us 6.916 is equal to x minus 127.1. Now we're going to add 127.1 to both sides. cancel over here, and x is equal to 134.016. Okay? I feel like I did something wrong over here. Negative 6.916 plus 127.1. Nope, that's correct. I got it right. Okay, so now what we can say, how much candy is in the middle 55%? Well, it's between this number and this number, but let's go ahead and round them. So it's going to be between 120 up to 134 pieces of candy in each bag. And so what you've done here, what we've done is we have gone all the way from the beginning. We took the data, we found the standard deviation and the mean ourselves, we set up a normal distribution curve, then we answered proportion questions, we answered how many questions, and now here we've answered cutoff score questions or the scores that cut off certain percentages, okay? And this is everything that you need to be able to do for this very first unit in Introduction to Statistics. If you can do all this, you are in very good shape and you have a strong foundation to now move into higher level skills in the area of statistics, okay? Have a great day and get ready for that test.